Hello, everyone. My name is Matthew Glennon. I'm a freelance math tutor, and today we're going to be doing the fifth and final video on my introductory series to factoring, simplification, and the distributive property, with today's focus being on the latter of those, the distributive property. This has been a really fun, i- interesting series to sort of create, as this was my first experience with creating videos for tutoring. And I hope that you guys have enjoyed each one of them. And if you enjoy this video or you would like to work with me as a tutor, please feel free to reach out and we can make a plan to either help you or your child um, in their next steps for mathematics. And with that said, I hope you guys enjoy this video. Thank you all so much. All right, guys, let's hop right into the distributive property. So, the definition that I would use for it is that all it is a property in math which states that multiplication can be carried out across groups of terms by using parentheses. Now, when we talk about terms, that's just anything in math that is separated by an addition or subtraction sign. So, for instance, 3x would be one term, and 7 would be another one in this example down here. But notice that 3 and x are allowed to be in the same term because they're not separated by they're not separated by addition or subtraction. And notice that we're referring to them as a group that is put together via parentheses, which means that this is saying 3 times the group of x plus 5, or as I like to think about, 3 groups of x plus 5. Now, before I go into what the actual property tells us to do, I'm going to write it out so we can see how it works ourselves. Now, we have 3 groups of x plus 5, and if we were to think of multiplication as repeat addition, we could write 3 groups of x plus 5 like this. X plus 5 plus x plus 5, and this would be 2 times of x plus 5, or 2 groups of x plus 5. And then we're just going to do it one more time to get 3 groups of x plus 5. Now, there are 2 properties that work for addition really, really well here that we can use to solve this problem. And those 2 rules are going to be, or those 2 properties are going to be the commutative property that says that for addition and multiplication, um, order doesn't matter. So we could do x plus 5. We could also do 5 plus x. And also, we're going to use the associative property, which means that for addition or multiplication, we know that we can group things together however we would want. Meaning, it doesn't matter where these parentheses go if all we're doing is multiplication or addition. Now, keep in mind, that doesn't quite work here because it has to be only one of them. So it has to be all addition or all multiplication. Order does matter and grouping does matter if you have 2 different operations, like up here. But let's use those so that we can move around all the x's and then group them together, and then move around all the 5's and group them together. So as such, we can count that we have 3 x's, and we'll add all of those together. And keep in mind, we're just going to keep the pluses because we're only dealing with addition. It'll be 5 plus 5 plus 5. Now, we could instantly add them all together and get our answer, but I'm going to use that same rule that we just used where multiplication is repeated addition. And if we think about it that way, that means this first one is the same as writing 3 times x would be the same as x plus x plus x. And then we could say plus, since we have this big sign in the middle, 3 times 5, which is the same as 5 plus 5 plus 5. And with that, we actually just did the distributive property, because how you would solve this is that you multiply 3 or distribute the 3 to each term inside of the group. It doesn't matter how many terms there are. You could have like x squared plus x plus 5, and you could do the same exact thing. But that's exactly how it works. And if you're ever doing these sorts of questions, you don't have to write it out like this each time. I'm mostly showing you how this does work so that we can understand it at the foundational level. What you would normally start with is just by, I like to draw these little arrows, that way we can see that we're doing distribution. And then you can just hop to 3 times x plus 3 times 5, which is what we have down here. And this will be the intermediate step that I would definitely recommend everyone write. A lot of times teachers also like it when you write this so they know what you're doing. And then all you'll do is you'll simplify. And by simplify, we mean just do the multiplication out. So 3 times x is the same as 3x. And 3 times 5 is just the same as 15. Which, if we did down here, which was the roundabout way, we would get the exact same answer. There we go. So that's how distribution works. And the cool part here is that even though we've been working with factors specifically up to this point, the distributive property can be done with anything as long as it's mathematically consistent. Meaning, unlike factors which can't be whole or which have to be whole numbers, we could use fractions, we could use decimals, we could use variables, we could use anything when it comes to distribution. And in fact, let's take a look here at 3/4 of a group of 3x plus 7, which is how you would say that as a sentence. It's just 3/4 of a group instead of 3 groups. And we'll do the exact same thing, where we'll do 3/4 times this first term, which is 3x. And since we're doing fractional multiplication, I will have a denominator of 1, which we can do because any number divided by 1 is just itself. And then we'll keep the sign that's in the middle. So if this was a subtraction, we would be putting a subtraction. But since it's addition, we'll just keep it as plus 3/4 times 7/1. All right, and now the only thing we have to do is multiply it out. So 3 times 3x is 9x. Divide by 4 times 1, which is just 4. And then plus, so we'll keep that plus again. 3 times 7 is 21 over 4. And this would be the distributed long form. Now, a lot of times, if you were given this expression to start and you had the choice to pull it into this property or this form, I would almost always recommend writing it in this form, unless there's a specific reason you need it otherwise. And the reason for that is it's hard to work with multiple fractional expressions at once or multiple fractional terms at once. When you look at it this way, it's a lot cleaner, especially if you get rid of the arrows, which I'll do. This is a lot cleaner. Having just 3x plus 7 is really nice. And this would be what we would call the simplified form. Now, with that said, the next half of this is teaching us how to start with this expanded form and reduce it back into this pre-distributed simplified form. And as a rule of thumb, we know it's simplified under one of two circumstances, typically, because we could write it however we would want as long as it's mathematically true. But there's two general rule of thumbs to tell if something's simplified. The first is if we have something like this, 9x squared plus 27, we would want the coefficient, or the number being multiplied by the highest power of x, to be equal to 1. So we would want this to be 1x squared plus something. The only time that we really wouldn't want it written in that form, outside of special cases, would be honestly this question right here. If we're working with a fraction, our main goal should be get rid of the fractions or pull out the fractions so we only have it in one place. And in that case, we would want to get rid of that 4 in the denominator while also getting rid of any common factors shared in the numerators, which is why we end up pulling out a 3/4. Notice how if we tried to pull anything else out here, the second number would become a fraction again. Technically, it's not bad, but it's not exactly simplified either. Now, that said, that's the only other case where I would say don't just have the coefficient be 1. Otherwise, try getting it to 1. And in this case, we can think about it as we are pulling out a 9. So to get that into the distributive form, we know that we're going to have a 9 out front. That'll be multiplied by everything. But since we're doing that multiplication, or that distributed multiplication in reverse, we're going to be dividing this time. So instead, we're going to have our starting point, which is 9x squared, and we're dividing out this number that we pulled out, which means we'll divide by 9. And we'll do the same thing over here to the second term, which is 27 ninths. Now, if we did all of this out, we know that 9 and 9, a number divided by itself, is going to cancel, keeping us with x squared. And then 27 divided by 9 is the same as 3, meaning our final answer, or our simplified pre-distributed answer, is going to be 9 groups of x squared plus 3. There you go. And the cool part with this, and I think I mentioned it before, is that factors have to be whole numbers. However, when using the distributive form, we're not necessarily factoring, even if a lot of times it's convenient to use a factor. Instead, we're pulling out any number which is convenient in this case, or would simplify it. Meaning we could factor out, or in air quotes, factor out a decimal or a fraction. But really all we're doing is rewriting it so it's in the distributive form. So let's look at this example. We have a negative number in front of the x squared, a -1 to be precise, and we wouldn't want this either. We would want it to be a +1. So what we do is we're going to pull out a negative, which keep in mind, we're really pulling out a -1, which I'm not going to write just because it's normally commonplace that if we just have -1, we write as negative. And we'll have negative x squared, or -1x squared. And since we're undistributing a -1 to it, we're going to divide by -1. Keep in mind that we're keeping this plus here. This is going to be important for this question. And we're going to have 4 divided by -1. Now, let's cancel some stuff out. We know that this negative here is going to cancel with this one, giving us just x squared up here. Now over here, this is the fun part. 4 divided by -1 is going to give us -4. So we could say x squared plus -4, or we could swap it using a term called keep change change, or a technique called keep change change, which looks like this. So instead of writing a plus, we're going to write a negative, and I'm going to just catch up to where we are. So we're going to keep x squared. We're going to change the operation from addition to subtraction, and then we're going to change what's called the sign in front of this term, which would have been a -4, to its positive counterpart. Meaning this part right here, we could factor out a -1 or just a minus sign, and we'll have -1 groups of x squared minus 4. Which this is particularly good if you have or if you have an equation where both sides are negative. You could factor out or undistribute a negative from one side and then just cancel it on both sides, which is really useful and used in a lot of upper level algebra and in calculus. Now over here, as we can see, we have a decimal, which if we were factoring, this would be a problem. Since we're not factoring, we could easily work with this. So what we're going to do, we know that we want this guy to be equal to 1. So we're going to pull out or undistribute 25 hundredths or a quarter. And here we're going to do the exact same thing. So 0.25 x, can't forget the x. We'll divide by 0.25, which even though that looks really scary and gross, a number divided by itself will always just be 1. And then we will add, and now this is the tough part, 1 divided by 0.25, which at this level, a lot of times you can ask your teachers if you would just be able to put this into a calculator, and that works fine. However, let's use this as a moment just to quickly brush up on how to divide decimals. So what we do, I'm going to write 1 And then I'll do the little division sign, and I'm going to draw an extra amount here, just so we could see. And we're dividing by 0.25. Now, one thing here is that since this is a fraction, we could multiply the numerator and denominator by 10. It would be the exact same thing, which means if we move this decimal 2 points to the right, oh, geez, it deleted itself. Pop, 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 pop. There we go. Meaning the decimal is now here. We could move the decimal that would normally be at the end of this one 2 places over, which would just give us 100. Now I'm going to clean this up a little bit. You could draw the little arrows, but for us, I don't think it's necessary to keep them. And then we have 100 divided by 25, which we'll know that 4 quarters goes in a dollar. So we know we get 4. And the reason that this is important is because we're saying 1 divided by 0.25 is 4. And so our final answer will be 0.25 and then parentheses x plus 4. In this one is incredibly useful, especially if you're working with equations. Not having to worry about all of the 0.25s or being able to just divide out the quarter here is really helpful. It simplifies equations and expressions so much. And I would definitely recommend this, especially when you start getting into higher level math, especially when you get into like 9th or 10th grade. This is a really important skill to know. Now, last but not least, and this one's kind of a footnote, we could do the same thing when we have expressions that are all x's. Normally, we would want to reduce the power of x as much as we can, or pull out x and simplify it when it's possible. And this is especially important when you start working with quadratics, which is not going to be covered in this video, unfortunately, but it is an important step to know all the same. So with that said, they both have x in them, and what you do is you pull out the highest power of x you can without going into, what's it called? X is in the denominator. And in this case, x squared and x can both be divided by x. So we'll do x groups of, and it'll be the exact same thing as before, x squared divided by x plus x divided by x, which in the previous video that I did, I covered how you could simplify expressions like these. As just a quick reminder, all you do is you pick the side that has the larger exponent and you subtract the exponent of the smaller one. In this case, it'll be 1, which is always there, but we normally don't write it, which means this will be equal to x groups of x plus, and if we look, x divided by x, it's okay if we don't know what the value of x is. We know it cancels itself. So it'll just be x plus 1. And there we go. We have figured out how we could undistribute and distribute any number, including variables, including negative numbers, including fractions. All of these could be used together if we really wanted to. So you could undistribute a negative term of x with a decimal coefficient if you really wanted to. I hope for all of my students' sake that that's not the case because that is a little stressful to see, but you could do it. And with that said, this brings an end to the introductory series. We've been through a lot. We've learned first how we could factor, how we could simplify expressions using factors, how we could cross-cancel, which builds on that simplification process, how we could factor out and cancel variables. And then with this video, we took it a step further and learned how we could use those concepts in the distributive property. And with that, I would just like to thank all of you for joining me so much. It meant a lot to start this, and this was my first time doing videos in this format, so thank you all for bearing with me as well. And yeah, have a good one, everyone.